Have you ever wondered how an attacker could gain access to your organisation through an employee's home broadband? Well, today we're going to be looking at these exact types of unconventional attack surface and how best to manage them.
We're going to start off today by talking about what is an attack surface, what is this word we keep rambling on about, and what's really become a little bit of a buzzword bingo in the industry. What do we mean? Where does it start? Where does it stop? We're then going to start talking about how we're trying to challenge that approach, how we're trying to really redefine what we mean by your attack surface and where it starts and where it stops. Hopefully providing some examples that we've found over some of our recent engagements, some interesting, non-traditional, unusual approaches to finding these. We're then going to talk about how to immediately mitigate these things that we've highlighted. We're going to give some further examples of some additional research that we've been doing, and then we're going to give our key takeaways and our conclusion.
So when we talk about attack surface, we're talking about targetable assets, all which belong to organisations. As you can see from the diagram, this is a typical thing of what an organisation's attack surface might look like. So these are more of the traditional types of assets, such as domains, subdomains, and net blocks as well. However, when it comes to attack surface management, organisations tend to overlook these, tend to focus on these more traditional types of asset because they're relatively easy to track and monitor. However, it's these more unknown and unconventional types of attack surface that often get overlooked and can even provide an attacker with an easier way in.
So, with that in mind, we're going to start to talk about how we're trying to break that mold, how we're trying to say your assets don't start and stop at at domains, subdomains, IP blocks, net blocks, how other things that you post online, let's say your job postings, let's say public GitHub repositories, that feels like that's everywhere right now. But how an attacker can leverage your job postings online to see, oh, what EDR do they use? What AV do they use? How can I get insights into the target environment without even sending anything their way? Trying to break that assumption that vulnerability management and asset lists are always complete. These things certainly will not be on normal asset lists. And some of the examples that we're giving will hopefully show that.
So something we've seen quite frequently across the last couple of years is information disclosed through Postman workspaces. Now, information disclosure is not new. It's not a particularly novel attack, but we're still seeing it. We see this all the time. And as Jake mentioned, it's what we can do with this information that really makes it powerful. So Postman is typically used for building and developing out APIs, and it can be used quite collaboratively between teams as well. By default, Postman workspaces are actually set to personal or private, meaning only the user can access their own workspace. If a user were to set their workspace to public, then effectively the whole world's got access to this workspace. And as a result, we've seen things that disclosed in these workspaces like credentials, API keys, you name it pretty much. There are obviously cases where APIs are meant to be publicly accessible, so for example in cases of open banking, but cases where they are supposed to be quite private, then it's pretty much bad news. So let's take one of our client examples, but for the purpose of this presentation, we're going to redact his name and we'll call the client Tom as an employee. So Tom's a developer, he's working for a bank. He's currently been developing out this API. He's working quite late. He's got some really tough deadlines at the minute. His boss is saying to him, Tom, we really need to get this API done. We've got these deadlines. So Tom doesn't really think twice. He's like, oh God, I really need to share this with my team before next week. So he just decides to make this Postman workspace public. But he doesn't remember the fact that he's actually got his domain credentials in his public Postman workspace. So in this example, we've got a screenshot here. We've got a API request. So at the top, we've got the post request with the URL. And then a bit further down, we've actually got Tom's domain credentials. In this particular example, we didn't actually care about the fact that the API was exposed, but more around the fact that these credentials could be used elsewhere. So on our initial attempt, these credentials were actually invalid, but it wasn't until we incremented the number in the password by the number of months these credentials were actually exposed that we gained access to an internal application. And this is exactly how we found it. A really simple Google Doc query. As you can see, we've got sites, so we've supplied www.postmark.com, and then we've also got a keyword password, which we can swap out for anything such as API key or even the organization's name. This is really not rocket science. Most people have got access to a browser, right? So anybody can run this and assess your own exposure in relation to information like this.
So going on to our second example, very similar to the first one, where we talk about things that are publicly available. One of the interesting things that we spotted coming up again and again in a few of our engagements was the usage of online formatters, prettifiers, beautifiers, where people put code in there, make it look better, and save it. Now, what we found is the most popular formatter, the first result on Google, if you press that save button, it gets indexed by Google and we can find it. So on the right-hand side here, we've got an example. And here we've got a private key to someone's GCP instance, something that would allow us to instantly compromise them. But it's not always about RCE. We found so much information. And for us, information is power. Getting that information before targeting, before exploiting, getting this domain knowledge before popping a box. What we actually have found is we found reams of payroll information, huge blobs of payroll info. We found HR docs. We've also found huge password manager lists that people have just pasted in. So we found it in a very, very similar way. Again, a really simple Google Doc. Here we have site, jasonformatter.org. That's the site we're talking about here. And we also look for where password appears in text and also a random port. Again, you can customize this to your organization specifically, use your own keywords. And again, it's not rocket science. A lot of these examples we've stumbled on accidentally for FTSE 100 companies. And if we can do it, you can be sure a motivated adversary trying to target you definitely will.
So there are three things that we can do to immediately reduce our risk exposure in this area. First, being the obvious, remove any sensitive information, whether this be by contacting the employee directly or even contacting the website and submitting a takedown request. Second, we obviously need to make these workspaces private. By default, they should be private, but in cases where they are public, obviously make them private. And then lastly as well, assume these credentials have been compromised. Assume they're already in the hands of an attacker and make sure they're cycled. In the long term, we need to move away from using externally facing tools for things like development and collaboration, and instead look at internal solutions as an alternative. In addition, we also need to look at educating our developers and our employees around basic security concepts and the risks around disclosing sensitive information online. And then lastly, Troy Hunt said it himself, hack yourself first. We've given you some super simple examples to take away today. And don't just stop there, Do this kind of thing on a regular basis. Have a compiled list of different searches and queries tailored to your organisation that you can run perhaps on a monthly basis. And that will just help identify any cases of information disclosure at the earliest possible opportunity.
So, on to one of our last examples, and I think this is one of the most interesting bits of research that we've been able to do as of recent. However, everything that we found, we wanted to put some nice screenshots, but it all identified an organisation. It all called out exactly who we were trying to target. So what we found over quite a number of engagements was an increase in RDP being exposed externally. Now, that's not novel and it's not new. I'm sure most organisations have an RDP box, a dev box, a jump box, a test box exposed. Now, it's not best practice, but we know it happens. Oftentimes, when we're looking at our clients' net blocks, we will find these things. But we approach this differently. We started looking at IPv4 as a whole, using internet-wide scan engines, looking at can we find our clients' assets elsewhere? Can we find evidence of them being exposed externally? And what we found was a really weird trend. We found organizations that were solely based in the UK being exposed from Hong Kong, being exposed from India and Spain, for example. And what this was representative of was employees working from home. That's why this is called residential RDP. What we found is that people working from home with a variety of misconfigurations, a misconfigured router, forwarding their ports externally, were actually inadvertently exposing their domain RDP to the world. So essentially, offering corporate access through their router. And what we identified was quite a weird trend. If our internet-wide scans went off during UK business hours, for example, the results were drastically different compared to if we did out of hours. And what this represented was an employee turning their laptop on and turning it off. What we found was a variety of companies. We found FTSE 100 companies, local governments, police forces, all across these residential ISPs. So think Comcast, think Google Fiber, for example, inadvertently being exposed to their residential RDP. So we've got one example here that is a rough mock-up of some of the data that we collected. And on this slide, we've got an example. So this was a FTSE 100 company. They were exposing 3389, our traditional RDP port externally. They were exposing 3388, an unstandard port, but was also RDP, and then some web ports. What this actually was 3389 was exposing their corporate RDP instance, their work laptop exposed to the world. 3388 was their personal machine, so we could hop to that as well. And then additionally, 5000 and 5001 were their web server for their local NAS. So we had their network attached storage as well. And this represented a misconfiguration of their router or forwarding ports that they shouldn't have been. And this was really strange. It was really interesting to dive into how many organizations are potentially affected by this. And fortunately, it is easy to fix. So if we start talking about how we reduce our exposure, fortunately, RDP is not new, it's not novel. So we'd like to look at locking down configurations, reviewing your workstation firewall, seeing if we can implement any detections for, can we see inbound RDP coming from external networks? Can we lock down the usage of RDP to only internal? Looking towards the long term, one of the interesting trends we spotted was that the usage of free VPNs was actually making company assets appear in weird places. So we found companies, again, solely based in the UK being exposed from Panama, for example. And with a variety of misconfigurations, an organization was inadvertently exposed to a really strange exit node of a free VPN. Again, allowing us, with some of the credentials we might have previously harvested, to gain domain access without using 2FA, without going through traditional remote desktop gateways. And again, moving towards the long term, what we saw was a trend of BYOD devices. So a lot of the devices we found were prefixed with desktop dash, the default Windows naming convention for a laptop out of the box. So what we spotted for one organization in specific was a bunch of their endpoints were spinning up, exposing, and just being exposed to the world. And really, this represented onboarding to MDM without any hardening, just instantly being exposed to the world. So review those policies, review those standards, and make sure a workstation that's not up to par can't join the corporate network. And again, we've said it previously, make sure you hack yourself first. This was just through internet-wide scan aggregation engines, things like Showdown.io, things like Census, or even do it yourself with MassScan. If we can do it, and we can find FTSE 100 companies, like I say, and governments, a motivated attacker trying to go after your organization might use this path.
So we've just included another three that we're going to explain at a high level. So the first example is information disclosure through packet capture files. Now, Packet Total allows users to upload their own PCAP files. So in cases where users have captured traffic within their organization, decided to upload it for analysis maybe, other users could then download these packet capture files. So as an attacker, I can then go onto Packet Total, search for this target organization potentially, download this PCAP file, and I've now got access to their internal network communications, basically.
The second example on here is to do with Docker. It was mentioned previously in our first talk today. We found the usage of Docker registry by free users, by users that aren't paying for the pro subscriptions, by default are exposed externally. So we found instances of images for corporate builds being exposed which had license keys, internal domain information, configured hosts files that gave us a suggestion of what their corporate structure looks like internally. We found paid professional software. Again, this isn't RCE, this is information, and for us, that's just the start of a piece to the puzzle to build a compromise.
A classic example, information disclosed through public Kanban boards. So in this case, we've supplied Trello as an example. Again, Trello is used quite a lot for collaboration, similarly to Postman. And we've seen all sorts on here. We've seen company HR documents. We've seen, I think we've seen incident escalation process documents as well, which is can be quite shocking. And also, the classic things like credentials and other sources of information as well. So as I mentioned, we've given you some examples now, some more in depth and some more at a high level, all of which we consider to be possible starting points for our attacker, and these ones in particular. So cast your minds back to Tom. As we know, Tom has disclosed his domain credentials within his Postman workspace. As we also know, Tom has been working from home like the rest of us for the last couple of years. His corporate workstation is exposed in RDP. His router is also misconfigured, meaning his RDP connection is exposed to the internet. As an attacker, I can now access Tom's domain credentials through Postman. I then see his RDP connection exposed to the internet, so I can then authenticate with these credentials through his RDP session. As a result, I then get access to Tom's organization's internal network. Also remember the fact we've also got these packet capture files, so we pretty much know the entire organization's Active Directory structure. So pivoting around becomes dead simple. We've also got NTLM hashes within this packet capture file as well, so pivoting between machines becomes really easy for us. Don't forget, Tom works for a bank, so we gain access to API credentials for a payment API. And as a result, we're able to authenticate to this API and gain access to card details and customer details. So not a good day for Tom.
So moving to try and wrap all of this up. As Katie mentioned, we've got Tom, but Tom is a real customer. So we were able to gain access using publicly available credentials. We were able to build a picture of their internal domain structure without even sending anything their way. So prior to even targeting this organization or letting on that we were after them, we've got massive amounts of internal information, we've got potential credentials, and we've also got APIs. So what I want you to walk away with is a few things. First of all, hopefully some of the examples that we've given have asked you to challenge your assumption regarding your attack surface. That it's not just made up of subdomains and domains and all the classic things we find in our asset lists, and that some of these unconventional attack surfaces, some of these information assets can provide an attacker with a viable path to getting a foothold. Similarly, we want to try and look beyond what we've got on-prem. We want to look beyond what we've got assets on, what we've got sensors on, like our assets, like our workstations, like our servers. And we want to try and figure out how the usage of these everyday services by our developers, by our internal colleagues, the usage of these free online tools can contribute to additional risk. How the usage of a free online tool like a code beautifier could potentially expose your credentials to the world, and thinking about these things to hopefully get ahead of them. Again, we've said it a few times throughout this, hack yourself first. And what we really mean about that is do it continuously. Establish a process internally to have a look. Just look on the internet. What can you find out about your company? You know it best. You've already got the internal domain knowledge that we're looking to gather. Have a search for your keywords. What can you find exposed externally? And see, I'm sure you'll find something. Thank you.